Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the sixth part. In this part, we're supposed to determine the standard equation of the hyperbola. We're given the vertices and the equation of the two asymptotes. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola. Now, before we jump into these examples, let's have a review on the parts, the two cases, and the equations of hyperbola. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus. And there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, a, b, and c, is c squared equals a squared plus b squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is c over a. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now, please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, so let's go over the problem here. We're given the coordinates of the two vertices, that is on negative 6, 0 and positive 6, 0. So the two vertices would be located along the x-axis. So it goes to the left at negative 6, 0. So this is our first vertex, while the other vertex is located across. Now, we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. And in this case right here, the midpoint between these two vertices is at the point of origin or at 0, 0. So I'm going to label that as letter C. Now, please also remember that since these two vertices are horizontal relative to each other, we can go ahead and say that this hyperbola that we're going to form in a little bit is an example of a horizontal hyperbola with center at 0, 0 or at the point of origin. So I'm going to go ahead and write that information up here. Okay, since we have a horizontal hyperbola, the general equation for the horizontal hyperbola would be x squared over a squared minus y squared over b squared equals 1. Now, please notice that the distance between the center to the vertex is represented as letter A. So I can go ahead and write that up here, that our A would be equal to 1, 2, 3, 4, 5, 6. So I'm going to label that as 6 up there. So I will plug this 6 into the A here, and the equation would look like this. So I left this b squared blank because we don't know what the b is, but we're given the asymptote. So what are we going to do is we are going to sketch the graph of this equation of the asymptote. Now we remember that this graph or this equation right here represents the asymptote. This tells us that from the center, we go 2 up, 1, 2, and we go 3 right because that's positive. So up to 1, 2, 1, 2, 3. So that's the first dot. And then, well, the next dot would still be the same thing. We go up 2 and then 3 to the right. 1, 2, 3. And we keep doing this. 1, 2, 1, 2, 3. And so we do the same thing across. That would be negative 1, 2, 1, 2, 3. So this is the next dot. 1, 2, 1, 2, 3. This is the next dot. 1, 2, 1, 2, 3. This is the next dot. So this is the first asymptote, which is an equation y equals 2 over 3x. So I'm going to go ahead and draw that asymptote up here. So the equation for this asymptote is y equals 2 over 3x. Now we are going to sketch the other asymptote, which is negative 2 over 3x. So from the center, I go up 2, 1, 2, and then I go to the left 3, 1, 2, 3, because we have a negative slope. Again, I go up 2, 1, 2, and then left 3, 1, 2, 3. Again, that's going to be up 2, left 3, 1, 2, 3. I'll do the same thing across. Down 2, right 3, 1, 2, 3. Down 2, 1, 2, 1, 2, 3. Down 2, 1, 2, 1, 2, 3. So this is the graph of the second asymptote with a negative slope. Now we remember that the central rectangle of a hyperbola will have the corners on each of these asymptotes, and it's going to pass through the two vertices. So we can go ahead and say that we can draw a line right here, and that's the first part of the rectangle. And we can also draw another line right here to make the rectangle. So this is the central rectangle for this hyperbola. This tells us that our co-vertex is located here and the other co-vertex is located down here. So I'm going to label this as co-vertex and this is our co-vertex. So therefore, we can go ahead and say that our B value, which is again the distance from the center to the co-vertex, would be 1, 2, 3, 4. And so I'm going to go ahead and plug that in here. That's going to be 4 squared. And I will simplify this equation of this hyperbola. So this is the equation that we have for this problem right here. Now, the coordinates of the two co-vertices would be... Now, let's determine the length of the transverse axis, that is the distance from the vertex to the other vertex, and the length of the conjugate axis, that is from the distance between the two co-vertices. So I'm going to go ahead and write that work up here. So the length of the transverse axis is 12, while the length of the conjugate axis is 8. So that we can go ahead and determine the location of the two foci. We remember that the two foci would be located C distance from the center. So to determine that distance, we are going to go ahead and use the equation C squared equals A squared plus B squared. So that we can go ahead and show that work up here. Okay, so our C value is plus minus 2 squared of 13, or in decimal, it's 7.21. So that's negative 5, 6, 7.21 should be somewhere around here. So this is our first focus. Well, the other focus would be 6, 7.21. This is the other focus that we have right there. So we can go ahead and write the coordinates of the two foci. From here, we can go ahead and sketch the hyperbola. Now, let's determine the eccentricity of this hyperbola. Now, we remember that eccentricity is C over A. Our C value is 2 square root of 13. So I plug that in here. That is over the value of A is 6. We can simplify this further. This would give us E is equal to, there's 1 2 in 2 and there's 3 2's in 6. So then the eccentricity of this hyperbola is square root of 13 over 3. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so let's go over the problem here. So we're given the two vertices. I'm going to go ahead and plot these two vertices up here. Now we remember that the center of the hyperbola is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. So in this problem right here, the midpoint between these two vertices is at 0, 0, or at the point of origin. So I'm going to label this as letter C. Now please notice that these two vertices here are vertical relative to each other, so that we can go ahead and say that this is an example of a vertical hyperbola with center at 0, 0. So I'm going to go ahead and write that information up here. Since this is a vertical hyperbola, I'm going to go ahead and write the general equation for a vertical hyperbola down here. Okay, now we remember that this A is the distance from the center to the vertex. In this case right here, the distance from the center to the vertex is 1, 2, 3. So I'm going to go ahead and write our value for A then is 3. So I will plug this 3 into this equation. And so this equation is going to come out. Now, please notice that I left the b squared blank because we don't know what it is. However, we are given the equation of the two asymptotes, and we're going to get the value of b squared from there. So that we go ahead and plot the first asymptote right here. So this is how it's going to look like. So we start from the center, we go up 3, 1, 2, 3, then we go right 7. 1, 2, 3, 4, 5, 6, 7. So this is the first dot, and we can continue doing that, but since there's no space in there, so we can stop from here. And so I'm going to do that across. That would be down 3 and left 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this is the other point for this asymptote. So I can go ahead and draw the asymptote now. Now let's draw the other asymptote with the negative slope. So what I would do is I go up 3 and left 7. So 1, 2, 3, 4, 5, 6, 7. So then that's where the dot is going to sit. I'm going to do that across. So I go down 3 and right 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this is the other point of the asymptote with a negative slope. So I'm going to go ahead and draw the asymptote. Okay, from here we can draw the central rectangle of this hyperbola. Remember that the central rectangle is going to cover the four corners of the rectangle and the two vertices and the co-vertices. So in this case right here, I can draw a line that connects the corner to the other corner right there. And I'm going to create that down here. And this is the central rectangle of this hyperbola. This tells us that our co-vertex is located at this point and the other co-vertex is located at the other point right here. So we can go ahead and write the coordinates of these two co-vertices down here. Okay, since we already have gotten the coordinates or the two co-vertices here, we can go ahead and determine the value for B. Remember, the value for B is the distance from the center to the co-vertex. So if we count it, that would be 1, 2, 3, 4, 5, 6, 7. So our B is 7. So we can plug that 7 in here for the B and we're going to square it. And so our equation for this hyperbola is... So this is the equation of this problem that we have right there. Now we are going to determine the length of the transverse axis, that is the distance from one vertex to the other vertex, and the length of the conjugate axis, that is the distance from the co-vertex to the other co-vertex. And then I'm going to go ahead and show that work up here. Okay, so the length of the transverse axis is 6, while the length of the conjugate axis is 14. Now we're going to determine the location of the two foci. Remember that the focus is located C distance from the center, and so the equation to solve for C is C squared equals A squared plus B squared, and I'm going to go ahead and show that work up here. So our focus is located C distance, since our vertex is vertically located relative to each other. So then we go up 7.62 and 7.62 down. So this is where the first focus is going to sit. So that would be 3, 4, 5, 6, 7.62 should be somewhere around here. This is our first focus, while the other focus would be 7.62 down. So this is our second focus. So these are the coordinates of the two foci. So now we're ready to sketch the graph of this equation that we have right here, which is a hyperbola. Now let's determine the eccentricity of this hyperbola. We remember that eccentricity is C over A. We've got our C, which is square root of 58. So I'm going to write that up here. Square root of 58 over our A is 3. So then we go ahead and say that our eccentricity, or the eccentricity of this hyperbola, is square root of 58 over 3. Did you get the same answers as these? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!